This is 8-3, solving right triangles. Here's some warm-up problems involving Pythagorean theorem and the distance formula. Pause the video and try these problems. Hit play when you're ready to see the answers. So in the last section we focused on finding side lengths, but now we can focus on side lengths and angles using SOHCAHTOA. So something a little bit different when finding angles. So this says use the trig ratio cosine A equals 24/25 to determine which angle of the triangle is angle A. So first off, I'm looking at what 24/25 equals as a decimal, which is 0.96. And I know that cosine is adjacent over hypotenuse. So let me try the cosine of angle 1 first. So cosine of angle 1 is equal to adjacent, which is 1.4, over the hypotenuse, which is 5. And when I calculate that, I get 0.28. So that didn't work. And if I try cosine of 2, I get adjacent is 4.8. So looking at angle 2 now, adjacent is 4.8 over the hypotenuse, which is 5. And that gives me 0.96. So this one worked. So therefore, angle A, this is how you write therefore angle A is equal to angle 2 because cosine of A, that 0.96, was equal to cosine of 2. So now you're going to try, keep in mind, they've already given us, but first I had made the decimal last time, this one already gave me the decimal. So also cosine A is equal to adjacent over hypotenuse. Pause the video if you want to try it on your own. If not, you can follow along with me. So I'm just trying both of these. So I'm going to start with cosine 1, which is equal to adjacent 3.6 over the hypotenuse 6. And I'm going to see what that calculates to, which is 0.6. So that one works. And just to make sure that I'm not doing something weird here, I'm going to try cosine of angle 2. Well, that's equal to 4.8 over 6, which is 0.8, and that one did not work. So therefore, angle A, angle A is equal to angle 1 because cosine of A was equal to cosine of 1. So if we could come up with a fraction or decimal for our sine, cosine, or tangent, then we can use the inverse trig function to find the actual measurement of an angle. So I can actually find the measure of angle 1 and angle 2 from the previous problem using inverse trig functions. Inverse trig functions include this -1, so like sine -1, cosine -1, tan -1. And on your calculator, if you look, usually right above the sine, cosine, and tangent is the sine -1, cosine -1, tan -1. So you would have to hit like a shift or a second button to get to that different color button above the actual button, if that makes sense. And I could show you in class if it does not. So we're going to just practice using that button. So if you type in cosine -1 of 0.87, keeping in mind our calculator needs to be in degrees, you should get 30 degrees when you do that. Sine -1 of 0.85, you should get 58 degrees. If you don't, you need to see me so I can help you. And tan -1 of 0.71, or inverse tan of 0.71 is what I should really say, is 35 degrees. So we'll be able to use trigonometry and or the Pythagorean theorem to find all angles and all sides of a triangle. When we do this, it's called solving a triangle, to find every side length and every angle measure. So in example 3, we're going to take a look at finding the side length using the Pythagorean theorem and trig ratios. So using Pythagorean theorem, we're able to find ST. So I can do a squared plus b squared equals c squared. 5 squared plus 5.7 squared is equal to, 5 squared plus b squared is equal to the hypotenuse, which is 5.7 squared. So I calculated for b and I got 2.74. So that was saying that ST is equal to 2.74, and the direction said to round the side lengths to the nearest hundredth. So 2.74. Okay, so now we can use our trig ratios to find everything else that we need. So I know I'm looking for angle T, and I have opposite and hypotenuse provided. So I'm going to use sine. It's going to be inverse sine. Is equal to opposite 5 over 5.7, and this as a decimal. Well, I can just do that in my calculator. So inverse sine of 5 over 5.7, and what I get is that the measure of angle T is about 61 degrees. We want to round to the whole number. So I have two options now. I can use triangle sum theorem, which states that all of the measures of the angles of a triangle add to 180. And so I can subtract, and I get about 29 degrees because I had rounded the 61. So measure of angle R is equal to 29 degrees. I can also use a trig function to find the measure of angle R as well. I can also check my 2.754 by using, let's say, cosine of angle T, my adjacent over the 5.7. Now that I know that angle T is 61 degrees. So there are a lot of ways to check your work on these problems. Okay, and this next one, I noticed they gave me two sides. If I want, I can use Pythagorean theorem to find the hypotenuse. So I got 9.01. Which makes sense as it's larger than the other two sides. It's about 9.01 since I rounded. And now from here I can use a trig function. So I can say maybe if I want A, I have opposite and adjacent that was provided. So I can do tan of A. Really it's just tan. I shouldn't write it this way because I'm kind of cheating. I just want to make sure I remember that I'm going to use the inverse. So tan of A is equal to 5 over opposite over adjacent, 7.5. And so when in my calculator, when I do tan negative 1 of the 5 over 7.5, I'll get about 34 degrees. We usually round those angles to the nearest degree. So this angle A is 34 degrees. So the measure of angle A is equal to 34 degrees. And then I can use triangle sum theorem, or the corollary where we already know we have used 90 degrees. So it's really just 90 minus 34 degrees. That would be the measure of angle C. So the measure of angle C is equal to 56 degrees approximately, since I rounded the 34 degrees. And now I've solved for every angle and every side. In order to do example 4, let's graph these points first. So this problem is asking us to find all the side lengths and the angle measures. So the first thing is I know that I have a right angle here. I can even check with my slope to see that these are perpendicular to each other. And if I just count the length of this one, it's 1, 2, 3, 4, 5 spaces. So PQ is 5. PR is 1, 2, 3, 4, 5, 6, 7. So PR equals 7. And then from there I can find QR using Pythagorean theorem if I want to. So I would do a squared plus b squared equals c squared. 5 squared plus 7 squared equals c squared. 25 plus 49 equals c squared. What am I doing? 74 equals c squared, square root both sides, and c is approximately 8.6 for that hypotenuse. So now I can find any angle measure I want. So if I'm looking at the measure of angle R, for instance, I could use, I've never put that number there. So I could use tangent opposite over adjacent. So I can go tangent of R is equal to opposite over adjacent, which is equal to 5 over 7. To find the missing angle measure, I need inverse tan. So inverse tan of 5 over 7, which is approximately 36 degrees, rounded to the whole number. So I have the measure of angle R, which is 36 degrees, and now I can find the measure of angle Q. So the measure of angle, I never wrote that, measure of angle R equals 36 degrees. Measure of angle Q is equal to 90 minus 36, which is 54 degrees. So now I've solved the whole right triangle. Here are the answers for the now you try, so make sure you can calculate those answers. Okay, since a 7% grade is a percent, it's really 7 over 100. Any percent is over 100. So that's where I start, and I know that if I had a triangle like this, it might look something like this, where we're talking about this angle measure that's at a 7% grade. Then the opposite would have been 7, and the adjacent would have been 100. So that means that I can take measure of angle A is equal to tan negative 1 of 7 over 100. And so when I calculate that, I get measure of angle A is equal to 4 degrees.